What if death isn't the end for you? What if you, unknowingly, are immune to any danger, beyond the reach of ultimate disappearance? Sounds like something out of the most audacious sci-fi movie, doesn't it? This idea, at its core, is so radical, so challenging to our deepest convictions, that it could fundamentally shatter our perception of the world. But it lies at the heart of one of modern physics's wildest and most thrilling concepts, quantum immortality. We won't waste time with lengthy introductions. To fully grasp the depth and paradox of this thought, we must embark on an astonishing journey. A journey that might not just broaden, but completely redefine your understanding of the very nature of life, death, and reality itself. And before we reach the climax, before we confront this mind-bending hypothesis, it's absolutely crucial to understand the fundamental building blocks from which this extraordinary theory is constructed. This means we must delve into the micro-world, where the familiar laws governing our daily lives simply break down, yielding to something entirely different. Everyday life is filled with predictability, and this sense of order often brings us comfort. Take a simple example. You kick a soccer ball. If you repeat this action 10 times, applying the exact same force and aiming it at the exact same angle, the ball, without a doubt, will always land in the same predetermined spot. Everything is predictable, logical, in perfect accordance with the laws of classical physics we learn in school and observe every single day. But what if I told you that at the very basic, fundamental level of the universe's structure, things are entirely different? What if the familiar laws describing our macro world cease to function as soon as we descend to the level of the tiniest particles? Imagine instead of a familiar ball, you're dealing with something incredibly tiny, elusive, an electron, for instance. You kick it 10 times in precisely the same way, with the same force and angle, trying to reproduce the conditions as accurately as possible. And what happens? The electron appears in different places each time. It doesn't obey our expectations, behaving unpredictably, as if it possesses its own incomprehensible will, governed by rules unknown to us. Here, randomness isn't an annoying exception, not an experimental error, but a fundamental, inherent rule that underpins everything that exists. It's this strange, unexplainable behavior of the micro-world, this inherent, intrinsic unpredictability that led to the emergence of one of humanity's most astonishing, counterintuitive, and undoubtedly most successful theories: quantum mechanics.
Quantum mechanics, in particular, offers a radically new perspective on elementary particles, one that overturns all classical notions. It tells us that, at the most fundamental level, an electron isn't a tiny solid sphere that you can easily visualize and pinpoint in space, as it would be in classical physics. It's more like something diffuse, mysterious, a kind of shapeshifter that doesn't exist in one specific location, but rather as a wave. But this isn't an ordinary wave that you can see or feel, like an ocean wave or a sound vibration. It's not a wave of matter or energy in the usual sense. It's something far more abstract and astonishing: a wave of probability. Its values can range from 0 to 100%, describing only the possibility of where the particle might be, or what measurement result we might obtain. To make this concept a bit more tangible, let's consider a hypothetical experiment. You fire an electron gun into your apartment. You launch an electron 100 times. In 80 cases, the electron appears in your living room, and in 20, it's in your kitchen. What does this tell us? It means the electron's probability wave is 80% in the living room and 20% in the kitchen. It doesn't tell us exactly where the electron is before we measure it, only its chances of appearing in one place or another. And the most amazing, most striking thing about this whole story is that this strange, utterly unimaginable concept works incredibly well in reality. It's not just a set of beautiful but detached formulas on paper. It's a cornerstone explaining how transistors in your smartphones and computers function, how atoms fuse in the hearts of stars, generating light, and how the entire world around us is structured and operates. But how on earth do you visualize a probability wave? It's not an iron core at the center of the Earth, not a flexible fabric of space-time that can be easily pictured. Quantum mechanics doesn't give us a clear, intuitive image of the electron itself, what it looks like, how it moves, or even what it tastes like. And if this theory doesn't describe the electron itself, if it doesn't give us its picture, then what does it describe? And how, for heaven's sake, could this possibly be connected to your potential incredible immortality? For over a century, scientists worldwide have wrestled with this fundamental question. What does quantum mechanics truly mean? What is its deeper ontological nature? And as often happens in science when interpreting something so enigmatic, they've inevitably divided into two main camps. You could compare it to a debate between linguists and literary critics. The linguists are the part of the scientific community that adheres to a pragmatic and highly influential principle known as shut up and calculate. For them, quantum mechanics is, above all, simply a set of incredibly precise mathematical rules, a kind of grammar for the theoretical language of the universe. This grammar allows us to make incredibly accurate predictions about the outcomes of any experiment, and in their view, that's absolutely sufficient. Trying to imagine what an electron really is, a tiny sphere, a blurry cloud, or perhaps even an anthropomorphic Detective Pikachu, is utterly pointless and unproductive. From their perspective, the goal of physics isn't to create beautiful, intuitive, mental images that align with our everyday understanding of reality, but rather to conduct experiments and perform precise calculations. So, they argue, just use the probability wave for your calculations, predict the results, and don't bother searching for hidden philosophical meanings that can only distract. But there's another side, the literary critics. They, conversely, cry out, "No! You don't understand! Read between the lines! There's a hidden meaning here, and it's much deeper than mere formulas." These scientists are deeply convinced that quantum mechanics isn't just a set of rules, but a fundamental story about reality itself, about how the world is structured at its deepest level. And they ardently desire to interpret it, to understand what is really happening when a particle exists as a probability wave. It is these literary critics who propose the most compelling, most radical, and simultaneously most unsettling interpretation, one that could literally redefine your entire understanding of life, death, and existence in general. This radical interpretation is called the many worlds interpretation, and it offers a truly astonishing, mind-boggling picture of reality, forcing us to reconsider the very concept of self. Many worlders believe that the universe isn't a single static whole, not a single unambiguous reality. On the contrary, it's an infinitely complex, constantly branching quantum state where absolutely all physically possible outcomes of any event, from the most minuscule to the most grand, coexist simultaneously. Remember our electron, which had an 80% chance of being in the living room and a 20% chance of being in the kitchen? If this interpretation is correct, the electron doesn't just choose one location, instead it splits. And along with it, what's most astonishing, you split as the conscious observer. In your living room right now aren't just 5, but countless versions of you. 4 of them see the electron in the living room, and 1 is seeing it in the kitchen. What does this tell us? It means the electron's probability wave is 80% in the living room and 20% in the kitchen. It doesn't tell us exactly where the electron is before we measure it, only its chances of appearing in one place or another. And the most amazing, most striking thing about this whole story is that this strange, utterly unimaginable concept works incredibly well in reality. It's not just a set of beautiful but detached formulas on paper. It's a cornerstone explaining how transistors in your smartphones and computers function, how atoms fuse in the hearts of stars generating light, and how the entire world around us is structured and operates. But how on earth do you visualize a probability wave? It's not an iron core at the center of the Earth, not a flexible fabric of space-time that can be easily pictured. Quantum mechanics doesn't give us a clear, intuitive image of the electron itself, what it looks like, how it moves, or even what it tastes like. And if this theory doesn't describe the electron itself, if it doesn't give us its picture, then what does it describe? And how, for heaven's sake, could this possibly be connected to your potential incredible immortality?
This means that whoever you are right now, at this very second, you were just one of these countless versions, experiencing only one of the possible events, either seeing the electron in the living room or in the kitchen. The many-worlds interpretation means that all physically possible worlds, every tiny quantum outcome, coexist right here, right now, but independently of each other, like the branches of an infinite, ever-growing tree. And there are incredibly, unimaginably many of them. Every minuscule quantum process, the decay of a radioactive atom, the collision with a cosmic ray, a random fluctuation of the electromagnetic field, gives rise to new and new worlds. Every second, billions upon billions of new realities superimpose upon each other, creating an unimaginably complex, branching fabric of reality. Of course, the linguists dismiss this idea scornfully. If these worlds can't interact, we can't verify their existence. That's not science, it's metaphysics. But what if I told you there's one way to test this outrageous idea? And to do it, you'd have to die hundreds of times. And so we arrive at the culmination of our journey to the most extreme experiment imaginable, the quantum suicide thought experiment. To implement it, we'd need just 2 electron detectors, but with one small addition. They're connected to a nuclear bomb, set up right in your living room. The conditions are simple and brutal. If the electron hits the detector in the living room, the bomb detonates, and you are irrevocably vaporized. If it hits the detector in the kitchen, you are perfectly safe and can breathe a sigh of relief. Now picture yourself sitting directly on this bomb, and your brave assistant makes the fateful shot from the electron gun.
A reminder, there's an 80% chance the electron hits the living room and you perish, and a 20% chance it hits the kitchen and you survive. All right, fire. In that moment, instead of a solitary beep, something far more profound occurs. If there were only one universe, then, with overwhelming probability, you would perish quite quickly. Sooner or later, the electron would inevitably trigger the bomb, and you would be instantly obliterated, your consciousness ceasing to exist forever. But if the many-worlds interpretation is correct, then everything changes dramatically. Every single time your assistant fires the gun, it's not just an event, it's a fundamental splitting of reality. Countless versions of you emerge. The vast majority of them instantly perish in those branches of reality where the electron hit the living room. And only one version, your version, survives in the branch where the electron landed in the kitchen. And here's the crucial, most important point. You, as a consciousness, as a perceiving subject, can only experience the outcome in which you survive. You're always the version that lived, the one that got lucky. No matter how many times you attempt this deadly dangerous experiment, from your personal perspective, from the perspective of your consciousness, you will always survive. At first it might seem like incredible, almost mystical luck, but at some point, your luck would become statistically, astronomically impossible for a single universe. Think about it. In a single universe, your chances of surviving 100 consecutive attempts when the survival probability is only 20% are roughly 1 in 10 duo-vigentian. That's a 1 followed by 70 zeros. If you, as a consciousness,
continue to exist and experience this over and over. If you've done this experiment 100 times and you're still here, it means the universe has just whispered its deepest secret to you. Yes, you killed hundreds of your versions in countless other worlds, but you are here. You are still experiencing events. You know that the many worlds interpretation is real. You are immortal. So what does this all mean for us? What incredible, perhaps even terrifying conclusions can we draw from this mind-boggling discovery should it prove true? If every possible quantum process always occurs in some branch of reality, then it means not only that there's an almost but not quite infinite number of versions of you, it means that, always, under any circumstances, there exists a branch of reality in which you, that is, your consciousness, gets incredibly lucky. Imagine, at some point, a deadly tumor begins to develop in your body, but then, by an incredible quantum coincidence, a cosmic ray or a random mutation kills it before it can spread. A bolt of lightning strikes at you, seemingly with fatal consequences, but a quantum fluke causes the discharge to miss by a full meter, leaving you unharmed. A heavy washing machine falls from a tall building, but all its atoms, in some incomprehensible way, quantum tunnel right through your body, causing no harm whatsoever. No matter how extremely high the probability of your death in any particular situation, there can always be a branch of reality in which you, your version, survives. Does this mean you can now recklessly rush into any danger? Can you start skydiving without a parachute or engage in extreme sports without bothering about safety because I will survive anyway? Not so fast. Herein lies a profound moral and existential dilemma. For every version of you that survives and continues to exist, there are billions of other versions of you who perish in other realities. And all these versions of you, these unfortunate selves, are just as real, feel and suffer just as much as you are right now experiencing this information. Therefore, if you value your current version, if your existence has meaning for you, you must also value all the other versions who perish in other realities. This raises a deep ethical problem. If you care about your own existence, you must also care about the lives of all your possible selves. By saving yourself from a falling washing machine in this reality, you are saving not only your current self, but also countless versions of yourself who might have died in other worlds. Your existence, your consciousness, your life, it's not just an isolated fact. Within the framework of this theory, it enriches the entire universe, adding a new branch of possible reality to its fabric. However, there's another side to the coin, another equally compelling reason to be as careful and responsible as possible. Unfortunately, we still don't know which interpretation of quantum mechanics is truly correct. At present, the many worlds theory remains just one of several possibilities, albeit a very elegant and logically consistent one. No scientist has yet sat on a nuclear bomb to conclusively test its veracity and risk their own existence for proof. What if the linguists turn out to be right and there is only one world? What if there are no other versions of you, no parallel realities in which you continue to live? Then, if that washing machine actually falls on you, it would be the definitive and irreversible end of your existence with no backup versions whatsoever. It would be great to know for sure, wouldn't it? If the many worlds idea is true, then no matter how unlucky you get in this particular reality, you will always know that somewhere in one of the countless branches of reality, you are incredibly lucky and you continue your existence. I would be grateful for any support. Please leave a comment, subscribe, and hit the like button. It really helps the channel.